Excuse me.
Hello. Hello.
Good morning, sir.
Very good morning. Wait for 1 minute. So last class we are completed movements. I think so. Okay. So here, last class we have movements. Clear? Tell me.
Yes, sir.
Yes. The page number is in your textbook 6.2.3. Topic is there. That is theorem. Non-central movements are independent of change of origin but not scale. So here we are having the current topic proof. Let u is equal to or ui is equal to xi minus a by h, wherever xi is equal to a plus ui into h, where a is known as any arbitrary point, h is the known as width of the class interval. Now you have got xi is equal to a plus ui into h. Now take the bar, x bar is equal to a plus h into u bar, and xi is equal to xi minus x bar is equal to h into ui minus u bar. Now our mu r prime equal to 1 by capital N, sigma I equal to 1 to N. Here not write and I equal to 1 to N. Fi into xi minus a whole to the power of r. This is the non-central moment. So 1 by N sigma Fi into wherever xi is xi nothing but h into ui. H into ui whole to the power of r. H into ui whole to the power of r equal to h to the power of r into 1 by n sigma fi into ui to the power of r. That is the rth non-central movement of variable x is h to the power of r times the rth movement, rth non-central movement of the variable u. So that is the effect of change of origin and scale, but not scale. This formula used for only for problematic point of view. Okay. Now coming to after completion of this, we can go to Shepard corrections. So why we need for Shepard corrections? So already we can find mu1, mu2, mu3, mu4, but these are the four central movements are not corrected movements. Why? Because the class intervals are not greater than 1 by 20th of the range. This assumption is generally true, but this assumption is not in general true. But some error is there. That error is known as grouping error. So avoiding for grouping error, W.F. Shepard and a scientist take the corrections for central movements. So mu1 is always first central movement. Mu1 is always 0 for any problem, for any point of view, it is always 0. Now mu2 corrected equal to mu2 uncorrected minus h square by 2. That is the second. And mu3, there is no question of correction. Why? Because the distribution is symmetrical, asymmetrical, we don't know. But generally mu3 corrected equal to mu3 uncorrected. So the Shepard corrections, Shepard does not touch mu1 and mu3. Shepherds take the corrections only for mu2 and mu2 and mu4. Now mu2 corrected equal to mu4 minus h square by 2 into mu2 plus 7 by 240 into h to the power of 4. That means where h is nothing but width of the class interval, I should take I equal to. Here in universe textbook, here I equal to, taken h is equal to I. So where I is the width or size of the class interval. Clear? Tell me. Screen కనిపిస్తుందా స్క్రీన్ పైన మాట్లాడండి.
Yes, sir.
Right. Okay. So these are the two corrections. So here you can see, in case of grouped frequency distribution, while calculating moments, we assume that the frequencies are concentrated at the midpoint of the class interval. If the distribution is symmetrical or slightly symmetrical and the class intervals are not greater than the 1/120th, that means 1/20th of the range. This assumption is very rarely true, but since the assumption is not in general true, the error is called grouping error. Avoiding grouping error creeps into the calculation of moments. Shepherd corrections is used to eliminate or avoid the assumption of grouping error. Shepherd proved that if number 1, the frequency distribution is continuous, and number 2, the frequency of taper up to 0 in both directions, the effect due to the grouping at the midpoints of the intervals can be corrected by the following formula. Mu2 corrected equal to mu2 uncorrected minus I square by 12. Mu3 corrected equal to mu3 uncorrected, and mu4 corrected equal to mu4 uncorrected minus I square by 2 into mu2 uncorrected plus 7 by 240 h to the power of 4, I to the power of 4, where I is the width of the class interval. Note, first and third movements required no correction as positive and negative directions. Positive and negative deviations themselves compensate the grouping error. Okay, so this is the super corrections on movements. Now coming to measure of skewness. Measures of skewness. Skewness means lack of symmetry. If the distribution is symmetrical or asymmetrical or non-symmetrical, whatever. If the distribution is symmetrical, it is positive skewness or negative skewness or no skewness. We study skewness to have an idea about the shape of the curve. Which can be drawn with the help of the given data. A distribution is said to be skewed if the distribution is said to be skewed means there is no question of skewness. That nothing but mean, comma, median and mode fall at different points. If the distribution is skewed, whether it is positive or negative, then the mean, median and mode fall at different points. That is, mean is not equal to median is not equal to mode. Nothing but the distribution is skewed. Now, second point is quarters are not equidistant from the median. That is Q3 minus median equal to Q3 minus median is not equal to Q median minus Q1. Third point, the curve drawn with the help of the given data is not symmetrical, but tested more to one side than to the other. So this should be known as skewness. So how to calculate the measures of skewness? Skewness can be measured in absolute terms by finding the difference between the mean and mode or mean and mode or mean and median. Number 1, that is skewness is equal to mean minus mode or mean minus median. Any positive value obtained by any one of the above formula is marked as the extent of the positive skewness. Any negative value obtained by any of the above formula is marked as the extent of the negative skewness. If the result is 0, then mean is equal to median is equal to mode. That means the distribution is symmetrical. The distribution not symmetrical, mean is greater than median, that is positive skewness, or mean is greater than mode, that is positive skewness. If the distribution is negative skewness, means mean is less than mode, or mean is less than median. Okay, so these are the formulas. These are the absolute measures of skewness. But whereas relative measures of skewness, when we are comparing the two series at a time, we can need an alternate procedure. That means you can take the relative measures of skewness. In a dispersion for comparing two series, we do not calculate these absolute measures, but we can calculate the relative measures called the coefficients of skewness, which are pure numbers independent of units of measurement. The following are the measures of skewness. Number 1 is First one is Carl Pearson's coefficient of skewness. Okay, so this is the most important. Carl Pearson's coefficient of skewness, number one. Second one is Bowley's coefficient of skewness. Now, Carl Pearson's coefficient of skewness, according to Carl Pearson's, for skewness of a series, the difference between the mean and mode only should be found out, because mean is an average which is most affected by the extreme values of the series, and mode is an average which is the least affected by the extreme value of the series. Thus, SKP equal to mean minus mode by sigma. Here, the printing mistake is there. See the students, in the textbook, we are having the printing mistake. SKP equal to mean minus mode by sigma. Write down on your notes. Escape is equal to mean minus mode by sigma. Sigma padaledu by sigma రావాలి ఎక్కడ ఖచ్చితంగా printing mistake ఉన్నది. See carefully. The mode is ill defined. When you are finding the mode, if the maximum frequency repeated more than one time, if the maximum frequency repeated only one time, you can calculate directly mode. If the mode is ill defined means what? If the maximum frequency repeated more than one time, so that directly you cannot calculate mode. You can calculate mean and median and substitute the empirical relationship between the mean and median and mode. That is mean minus mode is equal to 3 into mean minus median. Okay. So where you are having mean minus mode, you can put 3 into mean minus median. Here also the printing mistake is there. Escape is equal to 3 into mean minus median. Second place. Here escape is equal to 3 into mean minus median. The median badali. He has given the correction. So this is the correction. So 3 into mean minus median. And similarly by sigma. By sigma. Similarly here also by sigma. Clear? Students? Give the response, anybody?
Yes, sir.
Yes, sir.
Okay? టెక్స్ట్ బుక్ లో ప్రింటింగ్ మిస్టేక్స్ ఉన్నాయి. ఎక్కడెక్కడ మిస్టేక్ ఉందో నేను చెప్తున్నాను, మీరు రెక్టిఫై చేసుకోండి. ప్లీజ్ డూ ఫాలో దిస్ ఇంపార్టెంట్ పాయింట్. ఇన్ అవర్ టెక్స్ట్ బుక్ వీఆర్ హ్యావింగ్ సో మెనీ మిస్టేక్స్ ఆర్ దేర్. I will rectify where the mistake is given and I will give the correct values. Now here escape is equal to 3 mean minus mode by sigma. You should write here escape is equal to 3 into mean minus median by sigma. So if the maximum frequency repeated only one time in the distribution, you can use this formula, mean minus mode by sigma. If the maximum frequency repeated more than one time, you can use this formula, 3 into mean minus median by sigma. Okay? So, ఇక్కడ క్లియర్ చూడండి, ఇక్కడ ఫార్ములా 3 into mean minus median by sigma కూడా ఉండాలా, సిగ్మా పడలేదు అక్కడ. ఇక్కడ ఇది ఈ ఫార్ములా సంబంధించిన ఇన్ఫర్మేషన్ ఇది. ఓకే. Now, for relative measure of skewness, Pearson suggested that standard deviation should be taken as the division of the absolute skewness. This is because standard deviation many possess algebraic properties and is assumed to be the best measure of the dispersion. Carl Pearson's coefficient of skewness is given by coefficient of skewness is equal to mean minus median by sigma. Okay. Here is clear written. Mean minus median by standard deviation sigma. Coefficient of skewness. If when the mode is ill-defined, this formula is modified as below. Modified as below. One minute. The screen is jumped. 98 page number. Here. So here, when mode is ill-defined, this formula is modified as below. Coefficient of skewness escape is equal to 3 into mean minus median by standard deviation. Here is written clearly. Okay, right. Now coming to problems. Okay, right. Limit for Carl Pearson's coefficient of skewness is plus or minus 3. So the limits for Carl Pearson's coefficient of skewness is plus or minus 3. However, in practice, these limits are rarely attained. Okay. So SKP limits plus or minus 3. Maximum is plus 3 and minimum is minus 3. Lies in between minus 3 to plus 3. But you should not exceed plus 3. You should not exceed minus 3. Okay. Now, here is one example is there. Calculate the coefficient, skewness and coefficient. Calculate skewness and its coefficient from the following data using Carl Pearson's formula. Okay. So here is only for skewness. And heading matram Carl Pearson's coefficient skewness పెట్టిండు. అందులో రెండు భాగాలు ఉన్నాయి. ఒకటి escape is equal to mean minus mode and ఒకటి escape is equal to 3 into mean minus median. This formula is okay. Wherever escape coefficient of skewness, that is mean minus median by sigma. Okay, you should calculate skewness and as well as you should calculate coefficient of skewness. That is the difference. Okay. Now wages rupees 10, 11, 12, 13, 14, 15, 16. Number of workers 4, 7, 9, 15, 8, 5, 2. Okay. Wages 10, 11 ichadu. See the notes. 10, 11, that is x values. Number of workers f values, x square. 100 fx for the mean, fx square for the sigma. Okay. So mean is equal to x bar is equal to 1 by n sigma fx. Hello? X bar is equal to 1 by n sigma fx. So if you can fx 40, 10 into 4 40, 11 into 7 77, like f into x, that is totally sigma fx is equal to 639 by total frequency 50, that is 12.78. For the standard deviation, sigma is equal to under root sigma fx square by n minus sigma fx by n whole square. Substitute in this formula, you should get sigma value. That is sigma value is 1.527. The sigma value is 1.527. So highest frequency is 15, repeated only one time. So you can calculate directly mode. So mode is equal to 13. That is mode is equal to 13. That is the mode is equal to 13 value, which is having maximum frequency 15. Now skewness mean minus mode, that is minus 0.22. So negative skewness. So minus indicating what? Negative skewness indicates the data is negatively skewed. Carl Pearson's coefficient of skewness is given by escape is equal to mean minus median by sigma, mean minus median. So here is wrong, here is mistake is there. Mean minus mode. Now correction it is mean minus median kaadu, mean minus mode undala. Mean minus mode badala, ada median badadi, correction cheskondi. Cheskuntunara? Dear students.
Yes, yes.
Yeah.
Yes, sir.
Mean minus median kaadu, mean minus mode undala, MO undala akkada. So by sigma, mean is equal to 12.78, minus mode is equal to 13, by sigma is 1.527, so you should get minus 0.144. Skewness is negative, indicates that the tail of the left side of the distribution is longer or flatter than the tail on the right side of the indicating a strong mode. So this should be known as SKP. This is the most important question. It is occurs in the university examination paper. Skewness and coefficient of skewness. Skewness means mean minus mode or mean minus median. Or mean minus median. Okay. Or mode is ill-defined, that 3 into mean minus median. Escape is equal to mean minus mode by sigma or 3 into mean minus median by sigma. So these are the four formulas. One is skewness is equal to mean minus mode. Skewness is equal to mean minus median. అవి రెండు స్క్యూనెస్ సంబంధించినవి. కోఎఫిషియంట్ ఆఫ్ స్క్యూనెస్ సంబంధించినవి మీన్ మైనస్ మోడ్ బై సిగ్మా, 3 into mean minus median by sigma. These are the two coefficient of skewness. The above two only skewness. Okay. Now coming to Bowley's coefficient of skewness in page number 101. So Bowley's coefficient of skewness based upon only for quartiles. One is Q1 first quartile, one is Q2 second quartile, which is known as median. One is Q3, that is third quartile or upper quartile. Q1 is equal to lower quartile, Q2 is equal to middle quartile or median, Q3 is equal to upper quartile. Okay, these are the, so Bowley suggested the measure of skewness on the basis of median and both the quartiles. Bowley's coefficient of skewness is also known as quartile coefficient of skewness. Okay, it is used when the mode is ill-defined and extreme observations are present in the data, and also when the distribution is has open and end classes, that is less than 10, 10 to 20.
Sorry, sir.
Okay, clear? Kanipistundi vision? Okay, clear. So the diagram is known as, this is the center point median. This should be no upper quartile Q2, Q3. This is the lower quartile Q1. So this should be.
Sir, voice is not clear, sir. Yes, sir, same problem. What happened, sir?
Hello?
Yes, sir.
Hello? Is it only the host can share this meeting? The Bro is not connected. I think so. Braou Hyderabad is not connected.
Yes, sir.
The connection is failed from Hyderabad. Wait for 1 minute. I will check it.
Sir.
Only the host can share in this meeting. Host. Hello? Students?
Yes, sir.
Hello? Wait చేయండి కనెక్షన్ హైదరాబాద్ మాట్లాడినా కనెక్షన్ వస్తుంది వెయిట్ చేయండి.
Okay, sir.
Okay. Hello.
Yes.
Friends.
Sir.
Here. Right. ఇప్పుడు కనెక్ట్ వచ్చేసింది. So find the coefficient of skewness. Is one example there. 4 to 8, 8 to 12, 12 to 16, like so on and so forth. Corresponding frequency 16, 18, 30, like so on and so forth. Now you can construct CF, cumulative frequency, when you are calculating quartiles, which are known as Q1, Q3, Q1, Q2, Q3, whatever. You can construct cumulative frequencies. First frequency is 6. Now next frequency is 10. 10 plus 6 is equal to 16. Now 16 plus 18 is equal to 34, like so on and so forth. You can okay. Now here you can see okay. Here you can see CF. Find Q1. First of all, you can find Q1. The size of n by 4th item. That is 109 by 4. That is 27. 12 to 16 is the median class for Q1. So Q1 is the lies in between 12 to 16 by H by F. So that is L1 is equal to 12. N by 4 equal to 27 by 0.25. C is equal to 16. So the upper cumulative frequency 16. H equal to L2 minus L1 is equal to 4. Frequency is equal to 18. Substitute in this formula, you can calculate Q1. Again, you can go to that is the mean median mode. Now coming to
Sir, unable to hear.
second one is so n by 2 item. So 109 by 2, that is 54.5. 54, that is 16. Should not ID 60 that is 54.5 lies in between 6. So the class interval that is 16 to 20. Lower limit L equals 16. Substitute in this formula. Median Q2 is equal to L2 in the Q2 value వచ్చేస్తుంది. Q2 is equal to that is 18.73 వస్తుంది. Okay. Again coming to Q3. To find Q3, 3 into n by
Sir, your voice is not clear.
So 3 into 109
Your voice is too brief.
by 4, 109 by 5 lies in between. Where 81, here you can see 64 లో ఉండదు. తర్వాత 7 12 is
Your voice is
like
yes, sir.
so how is